He said kennel corn.
All right. So I want you to underline the 3.3 notes. This is not practice. This is the notes, right? Okay, so we're looking at, this is a continuation of what we've been doing. Today we're graphing proportional relationships. So this has to do with when two, if you look right down here, when two quantities, x and y, are proportional, the relationship can be represented by the equation y equals mx, where m is the constant of proportionality, other words known as the slope, right? So the slope is also describes when you have two different, variables, it describes how they relate to one another. So we're going to kind of talk about that. So the graph of y equals mx is a line with a slope of m that passes through the origin. Okay, the graph of mx is a line, underlined line, with a slope of m that passes through the origin. Okay? Okay. Now, so let's look at an example. Example 1, graphing a proportional relationship. The cost y in dollars of X ounces of frozen yogurt is represented by y equals 0.5x. Okay? So our method 1 is to make a table of values. All right? So notice on our graph, right, we have these values right here. These are our x values. See the little x down there? So we're going to plug numbers in to the formula to get out our data points that we will then plot. Okay? So let's choose, 0.5, and let's choose 1. We'll choose 1.5, and we'll choose 2. Okay? So then what we're going to do is we will put that into the formula. So y will equal 0.5 parenthesis another 0.5, right? So now, if you don't have your calculator, why don't you go over there and get it? Okay, so we're going to do 0.5 times 0.5. So when we do that, 0.5 times 0.5, what do you get when you do that? 0.25. All right, 0.25. So what is our data point then? It's data. It's not data.
I agree.
0.5, comma, 0.25. Okay, so then we are going to do the next one. And I'm not going to put the y this time. I'm just going to put what the equation is. 0.5 times 1 is just 0.5. And so our data point here is 0.5, comma, 0.5.
Cool.
And then,
what?
0.5 times 1 is just 0.5. Now on the next one, it's 0.5 times 1.5. Anything times 1 is that number.
Yeah, they say like the original number.
Yes. This should be 1. Thank you. Thank you, Daniel.
That's on me. So I had to make it.
All right, so then we're going to multiply. Okay, so we're going to do 0.5 times 1.5. All right, so 0.5 times 1.5, and that gives us 0.75. Is that what you got when you did that?
Yes.
He's considered it here.
All right, so that's going to be 1.5, comma 0.75. Then the last one is 0.5 times 2, and that's going to give you 1, right? So that's going to be 2, comma 1.
Hooray!
Okay, so now let's graph those. Okay, so the first point is 0.5 and 0.25. So for that, you have to kind of go in between to get that. So if you look right there, you go right to 0.5 and up to 0.25, which is like halfway between. Then the next point is you go right 1 and up to 0.5, like that. And then the next point is 1.5 and 0.75. So 0.75 is halfway between again, like right there. Okay, and then the last one is 2, 1. Like that.
No way.
Way.
Beautiful.
So then,
Here's a weird one.
okay. So then you're going to sketch your line like that. The equation shows that the slope is 0.5, so the graph passes through 0, 0, and 1.5. Okay, now, so as we look at this, what this means is that for each ounce, it cost basically 50 cents, right? 0.5. So how much does 1 ounce of yogurt cost? Right? How much is 1 ounce of yogurt? Go up to the cost.
50 cents. Wait.
Yep, 50 cents.
You just guessed.
All right, so that'd be 50 cents. How much is 2 ounces of yogurt?
Oh, $1.
It's $1.
$1. Okay. How much is 3 ounces?
$1.50.
Right, and we can look at that, right? If we get 2 ounces, we go up, and 3 ounces, we go up right there. Okay, so it is $1.50.
Hooray.
So it's 50 cents per ounce, right?
Yep.
Okay. So this is a direct proportional relationship. As you increase the number of ounces you get, it increases the amount of money that you have to pay. So it's a direct proportional relationship. Okay, so I want you to take a couple of minutes and do the try it. Okay?
Chaz, stop laughing.
Chaz,
I'm not even laughing.
Okay, let's get to it. All right. Shh. Bring it back down. Why not? All right.
I can't do it.
So I'm going to use
I can't really do without a baby.
is that what you want me to use?
Yes. Because I got 0.37 seconds.
0.5,
What?
1. And I'm going to use 2 and 3 when I do that. Okay. All right, so on the first one, it's 0.75 times 0.5. Okay, so that is going to be
0.375.
That's 0.375.
Have we really done two problems? Have we really done quite different problems? 40 minutes.
With word problems.
All right, so then we have 0.5, comma, 0.375. That's not easily graphable. So we're going to go, the next one is 0.75 times 1, which is going to be just 0.75. So that data point is 1, comma, 0.75. So then if we put in 2, 0.75 times 2 is going to give you 1.5. So that data point is 2, comma, 1.5. And then if we put in 3, 0.75 times 3, when you do that, you're going to get 2.25. All right, so that point is 3, comma, 2.25. Okay, let me fix that. Okay, so now if we graph that, I'm not going to graph the first point. I'm just going to graph the last three. So 1 and 0.75 is going to be like right there. And then 2, 1.5. So that's right on the cross, right there. And then we got 3 and 2.25, which is halfway in the middle, right there. All right, and then we need to draw our line like that. Okay. Now, there's our graph. So on the previous one, we said that, 1 ounce is 50 cents, 2 ounces is $1, like that. So what about here? How much is 1 ounce?
75 cents.
Yeah, it's 75 cents. Can I redo that?
Thanks, Ashton.
And so how much is 2 ounces?
$1.50.
That is $1.50. And then how much is 3 ounces?
What?
How much is 3 ounces? Tell me in money.
$2.25.
$2.25. So for every ounce, you multiply by 75 cents. Okay? Okay, so if we go on to the next one, example 2, the weight y of an object on Titan, one of Saturn's moons, is proportional to the weight x of the object on Earth. An object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. Write an equation that represents the situation. So what we're going to do is we're going to define these, right? So they said the weight of an object, y, the weight y, underline that part right there. The weight y of an object on Titan is proportional to the weight x on the object on Earth. Okay? Now, remember our general equation is y equals mx. Okay? So what did they tell us y was in this?
105 pounds.
Yeah, so Titan, right? The weight on Titan. So that's y. Y would correspond to this 105. And then, no, that's wrong. That's Titan, so it's 15 pounds on Titan. So that's the y over there. This is y over here. So x is what it weighs on Earth. X is what it weighs on Earth. So what we're going to do is put 15 in for x, y, and then we don't know m, but we do know that our x is 105, okay? So remember, m is going to be kind of the rate of change, okay? How it changes. So by solving this little problem, we will figure out what that rate of change is, okay? Now, how would I solve for m right here? How would I get m all by itself?
Divide 105 by 15.
No,
No?
the other way.
50.
I need to get m by itself, so I'm going to divide by 105. So it's 15 divided by 105. You said 105 divided by 15. So it has to be this way. All right, so what happens when you put that in your calculator? 15 over 105.
Big, long number.
Change it to a fraction.
That's not a function.
That's why I want you to use the other one. All right, so if we do 15
It's 1/7.
over 105, we want it as a fraction, so that's 1/7. Okay? So, in other words, m equals 1/7. Okay? M equals 1/7. Now, so then to write my equation, I'll go back to this original right up here, okay? And I'll say y is equal to, now my m is 1/7 and then x. So that is my equation. That's my equation. To get the weight on Titan, you take 1/7 the weight on Earth. Okay? So letter B, how much would a chunk of ice that weighs 3.5 pounds on Titan weigh on Earth? Now, is Titan the X or the Y? Correct. So this, where would this go into in my equation? Would it go in for the Y or in for the X? This is on Titan. Goes in for the Y, right? So this goes in for the Y right there. So we're going to say 3.5 is equal to 1/7x. Okay, so now I have, kind of going back to what we did on the whiteboard over here, I have this fraction, 1/7. So what am I going to do to deal with that? We're going to multiply by the reciprocal, right? That way it will cancel out, and I'm just left with x. So then you have to do the same thing on the other side. So basically it's 7 times 3.5. What is 7 times 3.5? Anybody else get that? Yeah. So it's 24.5 pounds on Earth. Okay, so can you do the try it?
What?
Would.
Oh, yeah.
Okay, so think about it. How much would a spacecraft that weighs 3,500 on Earth way on Titan? So is Earth the X or the Y?
X.
X. So this goes in for X. Okay, try that out. Plug it into the correct place in our little equation we wrote. Okay, so we're going to go y is equal to 1/7 times 3,500. So we're going to do 1/7 times 3,500. That's 1/7 times 3,500. So that is 500 what?
Kilograms.
Correct. Where?
On Titan.
On Titan. Good. Okay, so on example 3, the distance y in meters that a 4-person ski lift travels in x seconds is represented by this equation right here. The graph shows the distance that a 2-person ski lift travels. Which ski lift is faster? Okay, so this graph over here is for a 2-person lift. But this equation right here is for the 4-person ski lift. Okay? So we're going to come over here and put the 4-person. Its equation is y equals 2.5x. Right? So the slope of it is 2.5. All right? So that means, the way we interpret that, is it travels at 2.5 meters per second. All right, so how does that compare over here to the 2-person ski lift? Okay, so what we need to do for the 2-person ski lift is we have to find the slope, all right? So remember, our slope is the change in y over the change in x. So we have 2 points along our equation here. So to find our slope, right, we're gonna just write the numbers. We have 6, 12, and we write the other point right underneath it, 2, 4, like that. Okay, so our slope then is going to be, we'll do y minus y over x minus x. So that is 12 minus 4 is 8. And then 6 minus 2 is 4. And so that reduces to 2. So the slope there is 2, which means it travels at 2 meters per second. So it's going faster, right? The 4-person lift is faster than the 2-person lift because this goes faster. So the 4-person ski lift is faster. May not make sense, but that's what it's saying. Because it travels 2.5 meters a second. This one only travels 2. Okay, so then graph the equation that represents the 4-person lift on the same coordinate plane as the 2-person lift. And then we'll compare and interpret that. Okay, so if we get, so this is the this is the 2-person lift right here. So to graph that, we're going to need some data points, right? So we're going to make us a table, right, with our X and our Y. And I'm going to use like 2 seconds, 4 seconds, and 6 seconds, okay? And so our equation that we're using is, y equals 2.5x. All right, so if we put 2 in here for x, 2.5 times 2, well, that's going to be 5, right? And then if I put 4 in there, 2.5 times 4, so it's going to be 2.5 times 4, and that is 10. So that's going to be 10. And then I'm going to put 6 in there, 2.5 times 6. So that's 2.5 times 6, and that is 15. So this is going to be 15. So I'll use those points and I'll graph it over here. So the first point is 2, 5, which is right there. The next point is 4, 10, which is way up here. And then 6 would be 15, which is off my scale. So I'm just going to sketch it with these 2 points like that. Okay? So that is what the 4-person would look like. So it's moving faster. Probably had just like a larger engine so that it can pull the weight of those a little faster. Why is it steeper? It's steeper because it's going faster, so it covers more distance during the same amount of time. So for the same amount of time, it's covering a farther distance, is what that means. So what we're going to say is the graph of the 4-person lift is steeper because it moves faster. Okay, good job.